Welcome to Ask and Learn.
We want to show that the lines y is equal to plus or minus b over a times x are the slant asymptotes of the hyperbola x squared over a squared minus y squared over b squared is equal to 1. So what I went ahead and did to start was rewrite the equation just in terms of y, which we end up with this square root with the plus or minus. So the reason why I didn't pull out the b squared is because if we don't know if b is positive or negative, and we would have to have this absolute value, and I just don't want to have to write an absolute value every now and then. So just kind of keep that in mind. If you do pull it out when you're writing this, there needs to be an absolute value of b on the outside. But if we want to show that those are the slant asymptotes, what we need to show is that this function here minus one of those lines is equal to 0 when we take the limit as x approaches infinity. So, and I'm going to claim that the positive square root goes with the positive line, and the negative square root goes with the negative line. So let's go ahead and go through how to take these limits. So you might remember from the chapter when we talked about infinite limits that the technique we should use for this is to multiply by the conjugate. So let's go ahead and do that, because by multiplying by the conjugate we get rid of that square root. And remember, the conjugate is just we take the middle term and make it the opposite sign. So it'll be plus as opposed to minus. And then remember, anytime we multiply, we also have to divide by the conjugate, because we can't multiply by anything other than 1. Okay, so we end up with this here. Now when we go ahead and multiply out, remember that's just the difference of squares. So we're going to be left with, well, the square roots will end up just canceling out essentially. And we'll have b squared times x squared over a squared minus 1, and then minus ba with both of those squared, x squared, and then all over our conjugate still. So b squared x squared over a squared minus 1 square rooted plus b over ax. Right. Now notice if we were to distribute this b squared, then we'd end up with a positive bx squared over a squared. So that ends up canceling out with that there. And we're going to be left with, in the numerator, just b squared. Or negative b squared. So we'll have the negative b squared. And then all over our conjugate again. So b squared times x squared over a squared minus 1 square rooted plus b over ax. Now, if we were to take the derivative of this directly, you might notice that we'll end up with infinity plus, and I'm going to say ba infinity, like that. And the reason why I'm saying b over a is, well, if b divided by a is negative, we're going to end up with infinity minus infinity, and I have no idea what that means. So just to kind of get around that, what we're going to do instead is first multiply the top and bottom of this by 1 over x before we actually apply the limit. So now doing this, we'll have the limit as x approaches infinity of negative b squared over x all over, and remember when we pull that 1 over x into the square root, we have to square it. So that's why it will cancel out with the x squared that we have in there. So b squared. So it'll be 1 over a squared minus 1 over x squared square rooted and then just plus b over a. And now notice when we take the limit of this, well, the numerator goes to 0, that there goes to 0, and we're going to be left with 0 over the square root of b squared over a squared plus b over a, which is 0. So that there shows that b over ax is one of these slant asymptotes. Now, for this next one here, we can go ahead and follow the same steps. So first notice that these two negatives there cancel out, and we can go ahead and rewrite it with the BA or B divided by AX in front, and then follow the same steps. So just not to kind of bore you all with the algebra again, I went ahead and did this beforehand. So in this first step here, just like we did before, we multiplied by the conjugate. And after that, everything would simplify down to just b squared times 1 over x, or b squared over the conjugate. And what we're going to be forced to do once again is multiply by 1 over x, and we end up with this equation here. And then again, we can just go ahead and take the limit as x goes to infinity, so the numerator goes to 0. This part of the square root goes to 0, and we're going to be left with 0 over b over a plus b squared over a squared square rooted, which again is 0. So that there shows that the other line is also a slant asymptote.